चला जो मैं रिकॉर्डिंग स्टार्ट करो दे रही है स्टार्ट कर तेज चलेंगे आज थोड़ा तेज बिस्मिल्लाह। हाँ कल हम लोगों ने वाटरवेज को पढ़ा था ठीक है आज इंशाल्लाह ओहो light travels in the form of waves, okay, and they're electromagnetic waves. Like electromagnetic waves, they do not require any medium to travel. They can travel from like a vacuum and other space. ठीक है तो हमने तीन चीजें पढ़नी है लाइट के बारे में. लाइट में हम लोग पढ़ेंगे अबाउट रिफ्लेक्शन रिफ्लेक्शन एंड रिफ्लेक्ट ओके बिकॉज डायफ्रैक्शन इज इन योर ए लेवल्स तो अभी नहीं पढ़ना तुम लोगों ने. तो ये दो फिनोमेना पढ़ेंगे हम लोग. अच्छा जी उसके बाद हमारे पास तो लेट्स स्टार्ट विद रिफ्लेक्शन. So light waves reflect, and when they reflect, they bounce back. Okay, so they'll come like this. Okay, and they'll go like this. Like this. Okay, so incident ray and reflected ray. The line which we draw is called the normal line. And उमर तुमने लोगों के लिए ना आसानी कर दी है अब. शादीन की मामा पूछ रही है शादीन की मामा पूछ रही है सर will there be a video link for today's class. इससे पहले ऑप्शन नहीं था इसका. What should I say? Inshallah, yes. बस तुम पॉज करो एक दो दिन के लिए वीडियोस ठीक है. इनको वापस लेकर आने. हम एक काम क्या करेंगे मैं तुम्हें बोलूंगा बेटा वीडियो पॉज करो ठीक है फिर मैं बीच में पढ़ाऊंगा फिर वापस वीडियो स्टार्ट करना. चलो चलो एनीवे सो ये जिस एंगल से आ रहा है उसी एंगल से जाएगा. ये है आपका लॉ ऑफ रिफ्लेक्शन ठीक है. तो एंगल ऑफ इंसिडेंस इज इक्वल्स टू द एंगल ऑफ रिफ्लेक्शन. वो वो हाँ वाटर वेव्स देख रहे थे ना. वाटर वेव देख रहे थे बैरियर था. वेव्स हिट हुई थी वापस गई थी ठीक है. अब हम लाइट वेव्स के बारे में पढ़ रहे हैं ठीक है. तो रिफ्लेक्शन का फिनोमेना जो है देखो तुम्हारे पास मटेरियल तीन तरह के हैं जिसमें से लाइट पास हो सकती है. या तो मटेरियल होगा ओपेक या ट्रांसलूसेंट या ट्रांसपेरेंट. ट्रांसपेरेंट जो मटेरियल होते हैं उसकी सरफेस पे हल्की सी रिफ्लेक्शन होती है ना होने के बराबर. कि लाइट जो है वो हिट करती है कुछ बाउंस बैक होती है और ज्यादातर लाइट पास हो जाती है. अब पास होकर बेंड होती है फिर वो आगे निकलती है जिस फिनोमेना को हम रिफ्रैक्शन कहते हैं. जो हमारे पास ओपेक मटेरियल्स होते हैं जो लाइट को पास नहीं होने देते ब्लॉक करते हैं उसमें रिफ्लेक्शन होती है. अब वो भी डिपेंड करता है कि सरफेस शाइनी है और स्मूथ है या फिर रफ है ठीक है. जैसे आपके पास मिरर होता है तो मिरर इज बेसिकली शाइनी सरफेस. सो व्हाट हैपेंस व्हेन लाइट इज गोइंग टू स्ट्राइक इट इट्स गोइंग टू बाउंस बैक. Okay, so the phenomenon of reflection is occurring when the material is opaque. It does not allow the light to pass through it. Okay, so we can observe the phenomenon of reflection in our mirrors. So reflection is basically obtained in mirrors. Now mirrors can be of two types. Mirrors are either spherical or plane. Spherical mirrors are further divided into two types. Spherical mirrors are convex and concave. Okay, they're either convex mirrors or they're concave mirrors. Convex mirrors are like no, they're lenses. They're lenses. Convex and concave. Okay, mirrors are no more a part of the syllabus like it used to be. It's no more. So you just like I'm just giving you extra information so that you guys may know what the all stuff is. O levels may hai ye, but IGCs mein nahi hai. You just don't need to. So what's going to happen? This mirror is basically going to either converge or diverge light beams. Okay, you must have seen the shaving mirrors or the mirrors, the side mirrors in the car, the mirror for the rear view of the car. Okay, or like when you're traveling at sharp turns. Okay, then you see a huge mirror being placed, especially in the northern areas if someone is traveling. Exactly, isn't it? So we do have exactly. So we do have huge mirrors being placed so that you can see the sharp turns. Okay, or shaving mirrors हैं, who goes to the barber shop, so the mirrors are very common. ठीक है, वो जो पीछे लेके खड़ा होता है and see what he has done with your back. Okay, so exactly, those are the mirrors. Plane mirror is the mirror we have commonly at our home. So what is the difference between them? These spherical mirrors are either going to make your image like look bigger or make your image look smaller. Okay, for instance, a huge car will be, you can see it in a small mirror, so that has made the image smaller. Okay, and something like you put your nose in front of the mirror and it's going to be seen bigger, so that means a smaller nose is the image is bigger. But when it's a plane mirror, that means you are going to observe the image equal to the size of the object. Okay, so plane mirror, how the plane mirror works. For instance, if this is a mirror and this is an object being placed. Okay, so my dear students, a reflection is going to occur. Okay, so you'll have one ray, for instance, going and then passing like this. There huge amount of waves going. Okay, so we just draw two, because whenever there are two rays meeting, there will be image form. So we at least require two rays for the formation of image. So you can see here that the rays are not meeting. So what this mirror is going to do, mirror is going to take these rays back. Okay, and then join, and then what happens, this here the image is formed, and then the reflection will occur, and you can see the image on the shiny size or the polished size of your mirror. So this is the object, and this is the image. There are four. There are four. But you must know about this. There are four characteristics of plane mirror. Okay, image formed by plane mirror. There are four characteristics. Number one, image is virtual. What is a virtual image? The image which is formed behind the mirror. Number two, image is same size as object. Image is formed at equal distance. And number four, image is laterally inverted. Your right side seems to be your left side. So these are the four characteristics of plane mirror. Okay. Can we move on? So this is reflection of mirror, reflection of light. Okay. Because of reflection, we can observe different images. And okay, for instance, if so a ray of light goes like this, then it is bounced back. Okay, another ray of light goes like this and it's bounced back. So what the mirror is going to do, mirror is going to pick and join them at a point. So for instance, if the object is over here, the image is formed over here. Okay, and then it's the same distance. So this was about the mirrors. Okay, so you guys must know that whatever the amount of light is coming in, the same amount is going to go out. Now, how can we observe this phenomena? So for observing this, because this is in your paper 6, and paper 4 for the O-level students. So you're going to take a sheet of paper. This is the top view. Okay, just imagine that we are looking from the top. And then we're going to place a mirror over here. And these are the stands to clamp it out. What you're going to do, you're going to, okay, so now what you have done, you draw a line over here. And then using your protector, you're going to put another line over here with a certain angle. And you're going to take pins at a distance of 5 centimeters at least. Then you're going to observe from here that these two pins are going to be visible on the other side. So what you're going to do, you're going to place two pins one after the other by closing your one eye so that these all four pins are aligned on the same line. You can do this experiment at your home as well. Okay. So these all four pins must be aligned on the same line and you can join. Okay. Once you're done with this, so you're going to remove the mirror and you're going to like remove the pins, but the dots will be there. So you can join everything with a pencil and then you can put your protector over here because this angle you already knew that this angle was because you have taken this angle yourself. So now you're going to put the protector on the other side and these two angles must be same so that the law of reflection has been verified. So whatever the angle of incidence is, the same should be the angle of reflection. This is the incident ray and that is the reflected ray. Ayan, how much should be the distance between the pins?
Sir, can you repeat the question, please?
What should be the distance between the pins?
Sir, 5 centimeter.
Yes. Okay. Nextly, uh, what could be the other sources of error in this experiment? Because they do ask this in paper 6. Any Aziad, can you try? Like you guys
Yes.
are going to tell me three sources of error, three precautions we have to do.
Angle measured.
Angle is measured incorrectly. Okay. And
Line is drawn incorrectly.
line is drawn incorrectly. And if the pins are not straight, they're like bending somewhere. Okay. So this can give you another error because you're going to like make the angle or you're going to make the line wrongly. Okay. Pins not properly erected. Who is going to tell? What is the error that is due to the wrong positioning of eye?
Parallax error.
Wow, 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 wow. Wow, 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 wow. Ayan has given the right answer. Ayan, like I have some literally inclination and like devotion towards your answers. So whenever you give an answer, now I'm so happy.
Thank you, sir.
Okay, so just see, we are thinking and we're getting more and more and more answers from there. Okay, next, the parallax error can be there, and uh, blunt pencil. Okay, pencil might not be sharpened, so a blunt pencil can give different values. Okay, so pencil because like we're getting 38 angle over here, but you're getting 38.5 or 38.9 or 39. Okay, so the law of reflection is not verified because the angles must exactly be same. So these might be the reasons because of which you're getting the wrong answer. Okay. Okay, so this is how we verify the law of reflection. Can anyone quickly recall this? voluntarily? Who is going to try? Anyone?
सर इस एक्सपेरिमेंट को जैसे हमें रिकॉल करना है
Exactly, like what you have understood in
Okay.
English, if you can.
Yeah. प्रोसेस
Alright.
बताना है
Yeah, the method, and like how you have done this. Okay, I'll ask you questions. You're going to answer. Okay. So what we are verifying? We are verifying the law of deflection. The law of reflection. All of you must participate. Okay. It's really encouraging that all of you must participate. Okay. We are verifying the law of reflection. Okay. Habibeta, you can tell later on what's going on. Okay. Start.
basically you place one plain mirror on a
Mhm.
sheet of paper के ऊपर
Mhm.
होगा ना
Hmm,
and
बिल्कुल.
then you place two pins at a same at like 5 centimeters difference.
First of all, you have drawn a normal line,
Oh,
okay? And
yes.
at a certain angle, you have drawn a line, and then you have placed two pins with at least the distance between them 5 centimeter. Very good.
Okay.
Next, okay.
And then I think the reflection of the pins
Mm-hmm.
are able to be seen on the other side of
Mm-hmm.
like the mirror. And I
Okay.
think you can like sketch that with your pencil.
Mm-hmm.
And then
You're going to
you
place
get
the pins. You're going to place the pins so that all the four pins coincide with each other.
okay. And then I
Okay.
think you make a line,
Mm-hmm.
like two lines, and then
Mhm.
you just have to make sure the angle of incidence and the angle of reflection are
Excellent.
both the same.
Very good. Very good. Very good. Nowadays, what we do instead of using the pins, there is another thing. The students in the other boards like in AQA, GCSE, UK में जितना चल रहा है वो सारा, they are not using this pin method. Rather, they're using a ray box. Okay. What is a ray box? There's a small hole and there is like an LED light coming in. Okay. It's just a single ray of light. So there is no need to have the pins. You're going to just have the ray over here, and then you're going to observe the ray coming from here. Okay, so you can just do the same thing using the ray box instead of the pin. So there is the pin method as well as the ray box method as well. Is this clear
Sir,
to all of you?
ये total internal reflection है या वो कुछ और चीज है?
This is simply reflection of in a mirror, in a plane mirror. That's it. Okay, simply a reflection.
ठीक है.
Okay, in a mirror. Now we're going to talk about the second phenomenon of light, and that is this clear to all of my bachas? Clear? Okay. The next thing is refraction. Refraction is basically the bending of light when it passes from one medium to the other. Bending of light. Okay. As the ray passes from one medium to the other. Can anyone tell me how many different mediums could be there from which the light can pass? Yes, Ziad, can you try? Or Omar, you can try? Yeah, what are they? Okay, these are the three types. Like, what can be the mediums in which light can travel? Can you name the type?
Solid,
Ah, okay. Yes, Ziad?
uh, through fluids and solids.
Fluids and solids. Yeah. So, can you specify some of the examples from there? Like
Only
light can,
transparent or translucent solids.
yeah. So, light can pass through water. That's one medium. Light can travel through air. Light can travel through glass.
Through a dense medium.
Exactly. So there are two types of mediums. Either it's going to be dense or it's going to be less dense. Okay. So if I say which is more denser, is it glass or air? What should be your answer? Glass is more dense and air is less dense. Okay. And if you talk about air and or if you talk about glass and water, are you sure? Anyone else? Glass is denser than water. Okay. But water is optically denser than glass. Hmm. 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 Okay. So we are talking. Firstly, we'll talk about the refraction of light in a glass lab. Okay. This is a glass lab. Okay. So how are we going to draw this? So be with me. This is transparent. This is not a mirror. Okay. Make sure about that. So light rays is going to come like this. Okay. And it's going to bend like this towards the normal. Okay. Because the speed decreases and then it's going to go like this. The same way so the angle is going to be the same. Okay. So what we can do here is we can draw a normal line over here. And this is going to be the incident ray. This is the normal line over here. This one is the angle of incidence. And this one is the angle of refraction. Okay. This is angle of incidence. And this one is the angle of refraction. And this one, which is inside it's called the refracted ray. It's called the refracted ray. And that one, which is moving like this. Okay, so the same angle is there. This is called the emergent ray. Emergent ray. So light is going to come, bend, and then go with the same angle. Okay. So can you see here that light is bending towards normal? Because glass is a more dense material, so it's going to slow down. Okay, it's going to slow down, and exactly. So it's going to slow down. Okay. So this is the refraction of light. Okay. We can prove this. Okay. By the same way, we can have a sheet of paper, put a glass slab in it. Okay. Use a ray box to have the incident ray, and then you're going to see the ray that is coming out. And by putting pins, you can plot this whole stuff. The two angles which we require are the angle of incidence and the angle of refraction. We have to do nothing with the emergent ray because it's of no significance for us. Okay. Then we are going to move towards the most important topic for today's lesson, and that's going to be the refractive index. जी हो गए. Okay. Refractive index is basically the property of a material. Okay. represented by n. There are two different formulae, and there'll be later on another formula for this. So the basic formula is n equals to sine of angle I over sine of angle R. This is sine which we use in trigonometry. Okay. And the other formula for refractive index is speed of sound in air over the speed of sound in the medium. Okay. Glass, air, water, whatever the medium the sound, the air is, okay, the light is traveling. So for instance, you have this. So you have to like either you'll be given the refractive index or either you'll be provided with the medium speed. Okay. Now I'll see who is my most intelligent student in the class. Okay. It's your test. And now I'll see who is the most intelligent student of my class. I'm repeating it. So it's a challenge for all of you guys. Ziad wants to say something.
The angle of incidence is 50.
Oh, you're not supposed to tell this.
What? You said the smartest students should answer.
But you have to come with the whole answer for the refractive index.
Okay, but like it's very easy. See, I don't have to do all that.
Ziad, you have already been with
Oh, wait,
me in
no.
this life. Okay,
Yeah,
no
angle.
worries. Okay. 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 Find the refractive index. हाँ बस अब निकालो. Find refractive
सर मेरे
index.
भी सर के ऊपर से निकला.
Ziad, your answer was not beneficial to the others. Let them do, please.
Okay,
Okay.
fine.
So refractive index is simply the sine of angle of incidence and the sine of angle of refraction. Okay, that's it. I think so. You have been given everything in the question. You just put the values in the formula and you get the right answer. It's so easy. Okay, you just put the values which you have been given. Sine is like trigonometry. Sine, cos, tangent. You're going to use your calculator. Like put sine theta, cos theta. So what is the answer you're getting?
Okay, I have my answer.
You have your answer. I know that. Okay, that's
Should I come out?
great. No. Please, one more minute.
Okay, fine.
Let all of them come up with the answer. Who is getting the same answer?
Hmm.
Anyone?
मेरा 1.53 आ रहा है.
1.53 aa raha hai. Okay. There's another answer 1.53. Okay. Ayan, what's your answer?
सर मैं कैलकुलेटर के अंदर वैल्यूज प्लग इन कर रहा हूँ. जस्ट 2 सेकंड.
Okay. Zabardast. That's perfect. Great.
और मुझे लग रहा
मेरा
था
भी
40 का
1.53 आ रहा
एंगल. अच्छा मुझे लग रहा था 40 का एंगल शायद वो एंगल ऑफ इंसिडेंस नहीं था. मैंने 90 से माइनस किया था.
Oh. Are you so intelligent?
नहीं. मुझे बस लगा था कि शायद ये इंसिडेंट रे नहीं था.
Exactly,
जो
you are right. You are right. Because the angle is always, which Ziad told you guys earlier. As soon as I put in the question, Ziad told us that angle of incidence is not 40, rather it's going to be 50. This is
oh.
this is how they trick you in the exam, and this is how they give you questions. Okay, so you are being prepared for that. Okay, so those who are in the class, it's literally beneficial for you. Okay, all right, my dear students. So you must remember this, please. Yeah, exactly. Angle is always from the normal. The refract angle of refraction is from the normal, so the angle of incidence must be from the normal as well. If you have just made the diagram, I have mentioned over there that the angle of incidence is not that one. And normal is always 90. Exactly. So the normal is always 90. Subtract from 90. Simple. Subtract from 90. Hence you- Yes.
So answer 1.5 ही है ना? 1.
Hmm. Hmm. Okay. Very good, Ziad.
सर फाइनल आंसर जो है 1.5 आया है.
Okay, that's fine.
नहीं मैं पूछ रहा हूँ.
Yeah, it's 1.5.
सर तो
Okay.
1.5 एग्जैक्टली कैसे आया? आप लोगों ने साइन 50 यूज किया, क्या किया?
जी sin 50 यूज किया. This formula is used when you're having the light ray coming from a more less dense in a more dense medium. Okay, but it's not always the case. Light can move like this as well. Okay, light can go like this, that it's going to enter, okay, from a less dense medium, okay, and go like this as well.
Sorry, तो फिर एक dense से less dense medium में जाएगा तो sin R over I.
Yeah, so this is basically where the refraction is occurring. Okay, so now the formula changes, and we are going to, okay, so basically this is angle of incidence in this case, and this is angle of refraction. Okay, so now the formula changes, and it is going to be sine R over sine I, and the case is less dense from a more dense. Okay, is this clear to all of you?
यस सर.
Okay, now the next question. Yeah, you guys haven't studied trigonometry now, so I don't think so कि अभी तुम लोग inverse निकाल सकोगे. So students who have done trigonometry, they must try Okay, and I'll just wait for 2 minutes and then I'll explain you this. Those who have done this, especially Ziad and my O-level student, you have studied this trigonometry. I'm not sure whether Habiba you have studied or not, but Ziad has
जी
studied
जी पढ़ा
trigonometry.
मैं पढ़ा है मैंने
Okay, so you guys can attempt this 2 minutes, okay, and then explain to the other ones. Even Ayan, you can give a try because sine inverse will be applied over here.
Okay, sir.
Omar, I can't say anything to you as well. Like, just go and ask your maths teacher why you have been taught. So, unfortunately, your maths teacher is also me. The topics are very much correlated now. Like, Alhamdulillah, like, there's so many students who I'm teaching all three subjects maths, physics, chemistry. So, like, I got literally puzzled when I can't say anything to them. Go and ask your maths teacher how to make subject. Okay, like, sir, you are our maths teacher. Okay, quickly.
सर क्या एंगल ऑफ रिफ्रैक्शन 43.8 मतलब 44 degrees
Okay, okay, keep your answer with you. Ziad, have you come up with the answer? Ziad is there in the meeting?
Sir,
Yeah,
मेरा बड़ा अजीब सा आंसर लगा.
same
Okay,
answer.
Ziad, what's your answer? Same?
43.85.
Okay. So Omar, you just see beta how we do this. Omar, the first thing is that again, this is not the angle of incidence. This is the angle of incidence. Okay, so that's 60. That's 60. Okay, n is going to be sine r. Sine r. Exactly. Great. 1.25 equals to sine of angle r, sine of angle I over sine of r. Okay. So Omar, you can just shift it. Okay, sine r equals to sine 60 over 1.25. So beta, you can just calculate this using the calculator. Can you see there in the calculator you have sine? You press sine. Okay. Yeah. So find out the find out the value for this. The whole thing. 0.692. Okay. Now, Omar, what you do, if you have to take the value of r, so sine will go the other way and it will become sine inverse. Okay. Now, what you're going to do, you're going to press shift, then sine, and then put this value. You'll get the value of. Oh, that's it. Okay. So you just put 0.692 in front of that and tell me the answer. So I can say 44. 44. Angle R comes out to 44. I hope it's clear to all of you. Ayan, if there are any confusions, do let me know.
Sir, ये easy था.
Easy tha. Bas these type of questions do come in the exam. Okay. So now, my dear students, you are being asked to find the speed of light in class. The same question. Okay. So speed of light in air is a constant value, and that is 3 into 10 to the power 8 meter per second. All right. So you do have n, and you do have your speed of light in air. I wanted to give you the formula. Just need to make the subject and find the value of speed of light in air in the medium. Just quickly do this.
Sir, ये कैसे करना था ये वाला?
Wait, is it the same class block from the first question?
Exactly. It's continued. Ayan beta, refractive index का एक और formula भी है. Okay, so you have to apply this formula for this one.
Okay, sir.
have my answer.
Okay, what's that?
2.4 times 10 to the power of 8.
मेरा भी यही आ रहा है.
उमर क्या आंसर आ रहा है दोबारा बताना. सही है, मेरा भी सेम आया. 240 100,000 आ रहा है, उसको मैंने वो नहीं किया है.
ठीक हो गया. ठीक है. So we have completed till refraction, but now we are going towards more detailed topics, and that's going to be total internal reflection and something after that. Okay, so we will be covering. Inshallah. Physics is a very interesting topic, isn't it? Like the subject is really interesting. Okay, believe me, this is one of the most you can say the dry topics, but this is really interesting. Oh my God, nahi, Omar, that is not good for your liver. Please, please, anything which is like stopping something is making something bad. Painkillers affects the kidney. Panadol is affecting your liver. It affects your metabolism. Okay, please, like don't overdose it. Please, please, please. Okay, अब रिकॉर्डिंग स्टॉप कर दो. मैं एक वाकया बताता हूँ.